Today we're going to talk about geometric means and how they relate to a specific type of right triangle when you draw in an altitude from the right angle to the hypotenuse. But the first thing we're going to do is we're going to define what a geometric mean is. First off, we've talked about where the extremes and the means go in a proportion. And we've learned that the product of the extremes is equal to the product of the means. In that proportion, if the means are equal, in other words, if this mean was x, this mean is also what? X. If the means are equal, it is called a geometric means. Okay? So if these two values are the same, you actually have a geometric mean. So in the first example, it says, find the geometric mean for each pair of numbers. In the proportion, they're asking me to find the geometric means. So where the two means are, what am I going to put there? X. And what's going to fill in the other two places then? 6 and 15. And we simply would cross multiply. X times x is going to give me x squared. And 6 times 15 is going to give me 90. The opposite of squaring something is taking its square root. But remember that when I take the square root, it produces both a positive and a negative. What should I do with this square root of 90? I should simplify it. What will go into 90 that I can take the square root of? 9. Goes into it 10 times. But what is the square root of 9? So this becomes plus or minus 3 square roots of 10. In the second example, they're still asking me to find what? Geometric mean. They're asking me to find the geometric mean. What am I going to put where the means belong? X. What's going to fill in the other two places? 4 and 18. X times x, x squared. 4 times 18, 72. The opposite of squaring something? Square rooting it, it's going to produce a positive and a negative. But the square root of 72 will also simplify. 72 is divisible actually by 36. Goes into it twice. And what is the square root of 36? What's that? If I'd have done 9 and 8, it would have become 3 square roots of 8. But what would happen to this 8? It would become 4 and 2. And then I'd have 3 times 2 times the square root of 2, which is what? 6 square roots of 2. We good? Example 3 is actually a little easier, but I wanted you to see that sometimes we don't have to put the variable where the geometric mean is. Oh, what did it just do? Neither did I. I don't know what it did. There we go. Did it again. There it is. In this case, really? In this case, 36 is what? The geometric mean. What does that mean in my proportion? What's going to happen with this 36? It's going to replace where the x's were. It's going to go on the bottom and then on the top. It's going to be put in that proportion twice. What's going to fill in the other two spots then? 12 and x, because they asked me to find what it was a geometric mean between. I cross multiply. 12x equals 36 squared. And I'm going to divide both sides by 12. So I get 108. Everybody good? Okay. That's kind of what a geometric means looks like algebraically. Now we're going to talk about how we can find a geometric mean in a triangle. And the first thing we're going to do is we're going to look at what happens when we draw an altitude from a right angle in a triangle to the hypotenuse. And we're going to separate out the triangle that's on the left, which I've now highlighted in gray. And I'm going to separate out a triangle that's on the right, which I've kind of highlighted in a pink color. And I'm going to keep the orientation the same as my original triangle. So when I go to draw it out, I'm going to draw it so that the right angle is on the top and the hypotenuse is on the bottom. And I'm just going to do that on both sides. Okay? Now, keep in mind that this gray triangle, the right angle is what letter? The right angle is which letter? H. So I'm going to label that. This is my gray one. And this one's going to be my pink one. The right angle in the pink one is also what letter? H. Now, notice that in the gray triangle, angle A is in the gray triangle, but it's also in the whole triangle itself, isn't it? So if I keep the orientation the same, this would be where angle A is. What does that make this other letter in the gray triangle? I have an A, I have H. What's the other one? D. Okay? Everybody with me so far, what I did? I see yes, kind of a yes, no. Maybe. Pay attention on the second one. I think you'll pick it up. I separated out the pink triangle, but I wanted the orientation to be the same. So corresponding parts would be lined up. So I took and I kind of rotated it, or flipped and rotated, so the 90-degree angle is on the top. Notice that angle E is not only in the pink triangle, but it's in the whole triangle. So to make sure that the corresponding spot is lined up, this has to be angle E. Are you with me? What does that make the remaining angle then in the pink triangle? D. So, if I start out with my main triangle, the original triangle that I did, and I go A, D, E, what's it similar to in the gray triangle? AHD. And what's it similar to in the pink triangle? DHE. And what you're going to find is that we get a geometric mean that's created. In fact, there's 3 different pieces that end up being a geometric mean. Because when I start comparing similar triangles, notice that this piece, DH, is in both little triangles, isn't it? So it's a geometric mean between the two corresponding spots. Likewise, the leg of the original triangle, AD, is the hypotenuse in another triangle. So this ends up being a geometric mean, and so does this. And you're going to see it on our next slide. Okay? Same picture. We just added some letters here so we could represent the length of xw. We could represent it as a variable instead of writing it out as xw. B, that altitude, is a geometric mean. And I'm going to represent geometric mean by GM for the moment, just so I don't have to write it out every time. If B is a geometric mean in my proportion, how many times am I going to write it down? Twice. And I'm going to put it where the mean belongs. It is the geometric mean between the two parts of the hypotenuse that were created, which would be A and C. And it works because those two triangles are similar. Okay? So if you draw in an altitude is a geometric mean between the two parts of the hypotenuse that it separated it into. A leg of the original triangle, D, is also a geometric mean, which means in this one I'm going to put D down how many times? Twice. And it's a geometric mean between the part of the hypotenuse it's closest to, or adjacent to, A, and the whole hypotenuse, which here they said was F. Remember that F really could be represented by what? A plus C. So if I'm looking at F, I could also think of it as A plus C. Well, if this leg, D, was a geometric mean, what do you think E is? E is also a what? Geometric mean. What do you think it's a geometric mean between? C and F, the part that it's closest to, adjacent to, and the whole thing. And again, remember that F could be the same as A plus C. And this will make more sense once you see some numbers in it versus just variables. Questions so far? Yes.
Okay, so you said F is equal to A plus C, so why did you put D and E to F on?
Because D, right here, is a geometric mean between the part it's closest to, which is what?
A.
And the whole thing, which is F. And the reason I listed it as F is because in a minute when I put in numbers here, if this is 3 and this is 5, how big is F? 8. And you're going to be able to see it better once you put numbers in the problem. Okay? Everybody good? I can turn page. So let's take a look at what it looks like when we put numbers in it. Okay? 2 number 4s. Don't know why. But we're going to do this number 4 first. What is W in this problem? W is a geometric mean. If it's a geometric mean, when I go to set up my proportion, what does that mean? It goes in 2 places. What is it a geometric mean between? 6 and 4, the 2 parts of the hypotenuse that it created. Okay? We cross multiply. W squared is equal to 24. And the opposite of taking the square of something would be square rooting it. Normally, we would consider both the positive and the negative, but why would I throw out the negative in this type of problem? Because it's a measurement, and I'm not going to have a negative measurement. And when I take the square root of 24, again, this is going to be 2 square roots of 6 in simplified radical form. The square root of 4 would have been 2, and 4 times 6, so it would be 2 square roots of 6, and 6 won't simplify. If I go to the second example 4, what is x? It's a geometric mean. So x is going to go in my proportion twice. What is a geometric mean between? I don't quite agree. 4 and what? 4 and 10. The whole hypotenuse. Which is why I went back and said that f could be represented by a plus c. And I can see that. We good?
Oh, I have a question.
Yes.
Whenever you put the little numbers in, does it matter which one?
Nope.
Okay.
The only one that matters is which one? The geometric mean. Whatever you represent as the geometric mean is going to fill in those 2 spots. X times x is x squared. It's equal to 4 times 10, which is 40. The opposite of squaring it is finding its square root. And if I simplify that, this would be 2 square roots of 10. In example 6, what is y? Y is also a geometric mean, which means it's going to go in my proportion twice. What is it a geometric mean between? 6 and the whole thing, which we said would be 10. Y squared is equal to 60. And again, the opposite of squaring it would be finding its square root. And 60 is divisible by 4, goes into it 15 times. So when I simplify this, it would be 2 square roots of 15. Everybody good so far? Sometimes when you look at a problem, they put more than one variable in the picture. And you've got to decide where to start. They didn't give me anything about the altitude, so I'm not even worried about it. If I started with x, what would x be? A geometric mean. But what would be a geometric mean between? Y and 36. I'd have 2 variables. I obviously don't want to start there. What is 18 in this case? It's a geometric mean, which means this time instead of the variable being written twice, 18 is getting written what? Twice. What is it a geometric mean between? W and 36. And we're going to cross multiply. 36W is equal to 18 times 18, which is 324. And I divide both sides by 36. So W ends up being 9. Once I find that, I'm going to put that here in my picture. Is there a way that I can find y without using a geometric mean then? What is y? 36 minus 9, or 27. The advantage of putting the number back in the picture is it makes it more obvious that that's where the 27 is going to come from. Now I should have enough information that I can find what? X. What is X? It's a geometric mean. What is it a geometric mean between?
27 and 36.
27 and 36. Now, this time, I'm going to leave it this way for a minute. Because if I square root both sides, this might be easier for people to see. What is the square root of 36? But what will go into 27 that I can take a square root of? And 6 times 3 is? One of the reasons that I could simplify the square root of 972 so quick is when I looked at 27 and 36, I knew that 6 would come out of this and 9 would come out of this. Right? And so I knew what I could do. Actually, 3 could come out of it.
What'd you do with the square root 9? Under the...
It became 3, and what's 6 times 3? Right? 6 times 3 is 18. In other words, if I took 18 squared, 324, which is 18, it's going to go into it how many times? 3 times. Just makes it easier to see where it came from. Okay? What's y in example 8? If y is a geometric mean, I write it down twice. If I do that, though, what's going to happen? It's a geometric mean between 24 and 24 plus. Not a great place to start then, is it? What is 12? A better place to start. 12 is a geometric mean. Between what two numbers? 24 and W. 24W is equal to 144. Which means W is 6. And I'm going to put that here. That means my whole hypotenuse is 30. Now there's enough information that I can find y. Y is a geometric mean. Between what two numbers? 24 and 30. Y squared is equal to the square is equal to 720. And if I take the square root of that, or I simplify that square root, I'm going to get 12 square roots of 5, which means 144 goes into 720 how many times? 5 times. The only other variable left to find is what then? X. X is a geometric mean. It's a geometric mean between 6 and 30. X squared is equal to 180. X is equal to 6 square roots of 5, which means 36 went into 180 5 times. Everybody good? So, your assignment today is out of the workbook, and it is 7.4, Form G, both sides.
Oh, that's what you were doing. I thought you was using the mouse on the screen.
No, you can.
I was wondering how you was able to do it so fast.